Assalamualaikum warahmatullahi wabarakatuh. Okay, so this book is all about technique of integration for Form 4 and Form 5 student. Okay, first of all, my name is Izni Hazika binti Ibrahim. So, let's start. Okay, now this is the content. So, we're gonna learn about definition on integral, table of integration, simple integration, integration by part, substitution rule, and yeah, that's all. Okay, so this is the definition, which is integration can be used to find areas, volume, center points, and many useful things. But the easiest is to but it is easiest to start with finding the area under the curve of a function. Okay, so let's see. Okay, so this is a video about the mathematic facts. Okay, just for review. Fast forward. So this is all about mathematic facts. It actually a fun facts. So then we stop and okay, table of integration. Okay, what is table of integration? Okay, table of integration is okay as actually when you want to integrate a function, you can refer to table of integration. It is easier like this. Okay, this is the function. And this is when you integrate it, okay, it will become like this. This is the integral. Okay, then, okay, wait. Okay, here is an example of simple integration. So, I got it at YouTube. You just search simple integration. So, this is, these videos will come out. It explains pretty much a simple examples of a function. It's easier to integrate. Okay, so if you want to know more, you can go to the YouTube and search simple integration. Okay, now here is integration by part. Integration by parts, it's a bit harder than the simple integration because you have to pick your u. Means, okay, this is the formula, u dv equal to uv integrate v du. So this is what you have to pick. L Cephal logarithm, I inverse trigonometric, A algebraic, T trigonometric, and E exponential. Okay, so so how about we see the example? Okay, so if you want to do example of integration by part, okay. Now first, the formula. It is important to know the formula, so it is easier for you to solve it. Okay, the formula u dv equal to uv integrate v du. Okay, first determine the u and dv. Okay, remember our previous table yet. So first, okay, we have to identify what is x. So x is actually a algebraic. So x is a. Then e to the power of 6x. Okay, we know for the exponential, it is e. Then, okay, so we know based on the Liet, L, so we start u equal to x and dv equal to exponential 6x. Exponential to the power of 6x. So we just solve using the formula. Then after that, we substitute the formula all over again, and yeah, then we got the answer. So basically, if you want to know how to solve this, you have to master every part of the simple integration, or else it will be kind of hard for you to solve it. So master the simple integration first. Okay, then the second one is substitution rule. Okay, substitution rule. Okay, you can see that it can be divided into trigonometric integral, trigonometric substitution, and partial fraction. Okay, now let's see. Okay, what is this? This is Pythagoras identity. Okay, this is seriously important. You have to remember this. This is like I don't know, a map to something, and if you don't have this, then you will lost. Okay, so we go to the example. Okay, first example of substitution method, trigonometric integral. So example 1, integrate cos x sine to the power of 5x dx. Okay, now we let u equal to sine x. Why? Because sine x, we can see that here it's bigger than the cos x. So this you will find is easier if you know the simple integration. So then okay, based on the table of integration, so du equal to cos x, then dx is 1 over cos x. Okay, this is based on the table of integration. Okay, then substitute the equation, okay, we say that u equal to sin x, so u to the power of 5 here. Then the dx, okay, we can say that here is dx, so you substitute dx here, and yeah, just maintain the cos x. So you can see here that you can eliminate cos x, so it will become u to the power of 5 du. So then you integrate here, so we know if you want to integrate based on our table of integration, so 1 over 6 u to the power of 6 plus c. So then we substitute the u, so the u is sin x, then the final answer is 1 over 6 sine square root of 6x plus c. So simple. Okay, then next, okay, use half angle formula. Okay, this is also very important. Okay, sine squared theta equal to 1 over 2 bracket 1 minus cos 2 theta. Then the second one, cos squared theta equal to 1 over 2 1 plus cos 2 theta. Okay, the example. Okay, example 1, sine 2x cos 2x. Okay, it's if you want to do like the previous example, it will be hard for us because we can't cancel the cos x. Okay, if we cancel, there's we'll have whether the sine x or the cos x, so we cannot use the previous method. So in this method, we have to use half angle formula. Okay, so we choose, okay, sine squared x, so we just substitute. Then cos squared x, we just substitute. Okay, then we make it like this, 1 over 4 integrate 1 minus cos square root bracket 2x close bracket dx. So here we just do it like the previous no, here we just, okay, wait. Okay, so here surprisingly we will use half angle formula again, but then we have to make sure, okay, here is 2 theta, so here is 2 theta, okay, 2 theta equal to 2x, so here will be 4x because 2 in bracket 2x. Okay, understand? So this is 1 plus cos 4x dx. So this is also half angle formula, so it's so important. Okay, then it will become like this. Okay, CA. Okay, let's CA. Okay, so how to integrate this? First we have to integrate. So it will become, first we integrate cos 4x equal to sin 4x. Then we differentiate hashtag 2, number 2. So u equal to 4x, du equal to 4, dx equal to 1 over 4 du. Then, okay, we substitute back at here, cos 4x, so it will become 1 over 4 sin 4x. So from the previous slide, we know that, okay, this is what we have substituted earlier. Then we just expand, and yeah, we got the answer. Okay, understand? Okay, now next, okay, wait. Okay, I move a bit faster. Okay, next, trigonometric substitution. Okay, trigonometric substitution for me is kind of hard, but if you make sure you understand the steps, then it will be easier for you. Okay, for first step, you have to let. So, okay, for first step, let u equal to x, a equal to 4. Okay, you just have to follow this step. X equal to 2 second theta, then dx equal to 2 second theta tan theta, then okay, then the next step, second step, we substitute and integrate. So here we cancel what we can cancel. Okay, remember, sec theta equal to 1 over cos theta. Okay, then when we substitute and integrate, we got this 1 over 4 sin theta plus c. Okay, then the third step is to draw your triangle. Then the last answer is here. So basically, I will say that trigonometric substitution is quite hard, but if you want to know further, you can just YouTube the steps, and yeah, it's maybe when you see how to calculate it, then it will be easier for you. Okay, then next. Partial fraction. Okay, partial fraction for me, integration using partial fraction it has a lot of work to do. Okay, first you have to know what the factor in denominator, then the term in partial fraction decomposition. So okay, this is a step 1, step 2, step 3, step 4. So after that, okay, this is an example. So first you have to determine the factor in denominator. So when you then determine that, it will become like this. Then you have to expand it, find the unknown, b equal to -1, a equal to 4. Then so it becomes like this. You substitute back the value of b and the value of a. So yeah, it becomes like this. So based on the table of integration, this is the answer. So the second example is also quite the same as the first example. It's just that the difference in factor in denominator. So it is crucial to know what your factor in denominator, so that you know what term you can use in partial fraction decomposition. So this one you just have to the first step you have to separate it like this, then find the unknown, solve it. When you know the unknown, so you substitute back at the equation here, and now you get the answer. This all based on the table of integration. Okay, so that's all from me. My name is Izni Hazika binti Ibrahim, and thank you for reading and thank you for listening.